the main I think purpose of the recording is so that other people understand kind of what we do in this, and then or hopefully then want to join themselves in the future. Since this is only like I think our fourth one, so it's still kind of a new concept that I think people are still kind of they need, if they can watch the recording, they kind of get an idea of what it is. So yeah, so the purpose of this is to just kind of have a place where we can chat in real time, kind of informally. It came out of an idea like over a year ago with over email with some people saying like it'd be nice if we had like some sort of meetup over video where we could chat. Kind of the reason being is like the RISC-V meetups tended to be more focused on like hardware design or like verification, and not so much about the software side of things. And then yeah, so that was kind of the idea here. So kind of like the focus being both like software side of things, like open source projects related to RISC-V or RISC-V support and open source projects like Linux and U-Boot, and then also like uh, dev boards and things like that. So that's kind of like the general theme. Though if we do have people that are like hardware designers that join and want to talk about hardware design, that'd be cool too. It's kind of meant to be more informal than like the RISC-V meetups where there's usually like prepared presentations. And then usually, in addition to myself, we get a few other of the RISC-V ambassadors to join as well, which is always nice. And then the other thing too is if anyone has anything they want to present, just let me know, and you can share your screen. Or I mean, it doesn't have to be anything fancy. You could just like literally just like pull up something in your web browser that you want to show, or like demos. So even not today, but for the future, if anyone wants to do anything like do a little presentation on something or do a little demo or something like that, you don't even have to have slides. Just let me know. So the next one is going to be next Wednesday evening here in the U.S., which would be Thursday morning in Asia. I think, is that right, Fue?
Yes.
Okay.
Yes.
And then the next one that would be okay for Europe would be November 24th, which would be the evening, early evening in Europe, and then the morning here in the US. I do need to double check, like, because we've had this thing where, like, right now we're still on daylight savings, which is like our summer time in the US, and Europe switched back to normal time, no longer summertime. So um, right now it's showing 9 a.m. Standard US Pacific for the 24th, which is getting a bit late for Europe. So well, maybe I'll ping the mailing list and see what people think. The other thing too, which maybe most of you have joined, but if you haven't, there is a Google group called Open Hours under risk5.org, where I try and post like what's coming up. But it is also on community. So I'd recommend if you're interested, join the mailing list because I try and post there as well. But the other place you can look is on RISC-V community.risc5.org, and then we have them listed in there. And Megan, who's the person from RISC-V International, has been helping organize things, has got the dates in there for pretty much I think all the way through January. So you can also just let's pick one, go in here, click view details, and then you'll be able to RSVP. And then oh, I didn't fill out country, United States. All right, so then you submit, and then you should get an email reminder when it's time for the event, which I'm guessing most of you probably did because that's how you got in today. Let's see. Um, let's see who's on here. Well, I think several of the people on here are already on risk5.org mailing list, but I would say one of the main ways to know what's going on with the different working groups is there's a groups.io server that RISC-V runs, that a lot of the different email lists are on, and they're all public. So you can go in there and you can pull up a group. Let's see. Yeah, so you can see the different groups in here. You can click on them and you can go to the archives in here. So you can actually view the messages without subscribing. So all the all the emails are public, but if you want to participate in the mailing list, then you do need to become a RISC-V member. However, I think is the next, let's see. Yeah, so you can actually join free of cost as an individual or as a nonprofit organization. So is anyone on the call not a RISC-V International member, either individual or part of an organization? Because if you aren't, it's pretty easy. You can just go here and click on individuals, and then it's free of cost for individuals, which then will allow you to subscribe to the different mailing lists and participate. Also join meetings as well. And then one of the things when it comes to RISC-V International is I'm always trying to find links to things. So I would say one tip would be the best place to always look when you're trying to find things like about the standards and the organization and the working groups is this technical wiki landing page. Let me toss it into the chat here. Oh, and that if you aren't a member.
Just muted yourself, Drew.
All right. Thank you. Yeah, so this is a great place to look if you're wondering like, oh, where's the list of the different standards or the different working groups or like the Slack server or all these sorts of things. They're all in here. So this is a good place to look. And then for those of you that aren't familiar, Stefano's one of the technical project managers that does a lot of work organizing this information. So he's always a good person to chat with. Though I think also you can always email help@risc5.org about anything really, and then it'll get directed to like the right person. So if you're ever in doubt, you can email help@risc5.org to find out where something you're looking for might be. And then one of the other things I'm always looking at is the technical meetings calendar. So I try and attend the different like working groups and special interest groups that kind of relate to like a Linux system. So there's a lot of different groups that meet either bi-weekly or monthly. So actually coming up tomorrow is the RISC-V Dev Boards meeting, which is a pretty interesting one. It's definitely a bit early here on the West Coast, but for people in Europe, or even if you're up late like Fue, you can probably even attend from Asia. So this is an interesting call. It's both people that are from SoC vendors, board vendors, and then also people from distros. So I think Fue, you normally try and attend it. I've not been on it. I think in a while. Yeah, but so this is a good one if you're interested in dev boards. It's organized by Jeff. I think his last name is Schnell. So he's like the project manager that's in charge of this. So especially if you're someone from distro or like a hardware maker, it's a good one to join. There's also associated like email lists for it as well. Let's see here. The other ones that I usually try and attend are, so there's the cache, this is cache maintenance operations, which is kind of relevant towards SoCs that could run a full operating system like Linux. The other ones, let's see here. Okay, so this is one that's pretty relevant to like a full system that could run Linux, which is the advanced interrupt controller. So some of you might be familiar with the PLIC, which was the platform level interrupt controller, and the CLINT, which was the core local interrupter. So this was kind of local core interrupts and then also like external interrupts, like system level interrupts. So those have been replaced with new standards. That was part of this advanced interrupt controller SIG or special interest group, and they have monthly meetings, and that's usually led by Anup Patel from Western Digital. So that's a good one to attend if you're interested in what's going on at like a system level. The other one that's quite important, I would say, is the platform, and then this stands for Horizontal Steering Committee, which is basically, this is the group that's defining the RISC-V platform spec, which right now is focused on kind of both embedded systems with full SoCs running like a full operating system like Linux, and then also servers that would be running full operating system. So that one is a pretty interesting one. I'd recommend checking that one out. And there's a bunch of other ones too, depending on what you're interested in. I think, Alex, we have some mute Alex there. Yeah, so that's the technical meetings calendar, which if any of you weren't familiar with it before, I recommend checking it out. And if you become a RISC-V member, then you can attend these meetings. Let's see. Oh, one thing to keep in mind, if you've been involved previously, there used to be another calendar called Tech Groups, and we don't use it anymore. So you want to use the one called Technical Meetings Calendar. Let's see. Yeah, so then like new stuff, since this is kind of like boilerplate stuff, is one of the things I found to be quite interesting is the Android Special Interest Group, or SIG. They don't have any meetings that I saw on the calendar right now, but you can join the mailing list here. And there's not a whole lot of volume of traffic, but the reason I'm bringing it up specifically is that they had an interesting presentation recently at the CHIPS Alliance workshop. And the other thing you might want to check out is they do have a GitHub organization called RISC-V Android Source, which has a bunch of repos in it. And then the main reason I'm bringing it up is the chair of this SIG gave an interesting presentation as part of the CHIPS Alliance workshop a couple weeks ago. And I don't know if any of you had seen this, but if you hadn't, I think it's quite interesting. You can click on let me paste the link in here for this PDF of the slides. And then also it's part of a video that covers the whole RISC-V or the whole CHIPS Alliance workshop meeting. So if you click on that link there, it goes to this video that's like 3 hours long. And then the first presentation was this one about porting Android onto RISC-V. So I just grabbed a few screenshots out of it. So this was the video. It's not that long. It's like less than a half an hour. And it was pretty interesting. It talks about the work that they've done, which is, I think this is like over 100 Git repos that they've worked on, 2,000 files they've modified or added, and then 100,000 lines of code that they've modified or added across all the different things that you use in Android, which like I've not actually built the Android open source platform myself in a while, but like I looked recently and it's a lot. I think it's like a couple hundred gigabytes that you need to build it. So there's a lot there, and they kind of break it down into some different areas. So they added code to the runtime, which I think this is like the virtual machine. It used to be called something different back in the day, but now Android, the JVM in Android is Art. So I think technically it's not Java. I don't, it's like but essentially it's like the Java VM. So they've worked on getting that running on RISC-V. They've also done work on Chrome, and also a bunch of other like miscellaneous libraries and repos as well. So and then the final thing here, which was interesting, so like a big deal in Android is like this compatibility test suite, and they show how they're doing on there. So I think they still have ways to go in terms of performance, but the fact that it's running, I think is pretty exciting. Let me actually go back to the PDF, because there was an interesting slide in there about how they made the point that Android is the biggest operating system in the world right now, or the most by the numbers, which kind of surprised me when you think about it. It's like, okay, well, I guess that makes sense, because the majority, like everyone has a smartphone. Most people do nowadays, and I think the majority of market share for smartphones is Android. So yeah, they made the point that it's 42% of operating systems is Android. So I think
It's
their
also
point.
a
Yeah.
growing number of TVs that have Android in it now too.
Yeah. So it's a lot of things. So I guess, they were saying that, well, getting it running on RISC-V seems like it'd probably be a pretty important thing. So, and then, it's Android's like a lot of different things, right, that you need in the ecosystem. So it's a fair amount of work. And then, yes, was this? Yeah. So they actually have a demo of it running, that they show in the video. And I think we've talked about it previously too in this, but there was an earlier dev kit, like from like a year ago. I think Fue, you even have one of those, the older ones, and then there's now a new dev kit, uh, for running that you can run the RISC-V Android port on. So I think this one, instead of having I think this is the original one. I'm not sure. And then I think
ICE is
Yeah.
dual core. Yes, that's the original one, and
this is so this is
on sale, I guess.
yeah. So I think this is the original one, like the internal thing that Alibaba T had made, and that's what they showed off back in January. Like I think they surprised everyone with it's not T had ICE. There's a lot of other things. Well, whatever. There's a GitHub repo for the original ICE, and then this was the board for that. And then the one that I think on the October 12th, when they gave this talk, was when they announced this new version of it, which is essentially, I believe, the same SoC, but it's just a slightly different board design.
The demo one seems Coco.
Okay. And then yeah, so I guess this one you have LC DSI.
You can buy it online.
Yeah.
It's ICE is dual core. So yeah.
So this one has, I guess you can connect a screen to it with DSI, I'm assuming. And yeah, I guess that's the main thing. You connect like an LCD over, I'm assuming that's DSI.
Do we know what the GPU on that is?
I believe it's Vivante. So
Okay.
Let me see. Maybe if I search for C910 Android. I wanted to pull up the C910 T-head Android, the original one from on GitHub. Yeah, so this is the new one that came out. Oh, here it is. Oh, I guess this is a new blog post. Oh, hey, there's a new, I guess a new blog post on risc5.com about this, kind of, and then how to check it out and stuff. Oh, that's cool. Oh, here it is. That's what I've been trying to find. Yes, this one. I think this is the one that has the little video of the demo. Am I still connected to the video conference? Yeah.
I wonder
okay.
if GitHub is having problems.
Yeah, it's like my internet provider is not great here, so it often cuts out. But I'm still on the Zoom. So, anyways, if you go to that link there, that's the one that shows like the little video of someone using like the display on it. But I don't know if it lists it there, but I believe it is a Vivante, at least in the original one. But going forward, I'm not sure if it's still Vivante. But yeah, because a lot of
I looked at this before and it just says GPU. It doesn't say what kind it is. So I was just curious if you knew.
Yeah, I don't, going forward, I'm not sure. It might be something different going forward. I know that a lot of the other people working with RISC-V, I think Power VR is pretty common as well, Imagination. So I'm not sure. I guess from the aspect of Android, like oftentimes like the graphic stuff in Android is like using proprietary drivers anyway. So like I think with Android it's not a big deal because like everyone kind of expects the Android graphics drivers to be from the vendor to be proprietary, so it's not as big of a deal. But the reason I was excited about Vivante was like we have the Etnavev driver in mainline, which
Mhm.
for some of the Vivante GPUs they're like supported, though that's not like always the case, I think. But at least there's a path there. Whereas with like Power VR, it does not. It has a very poor track
Yeah,
record in terms of
w-
having an open source driver.
we've all got our fingers crossed that Imagination is going to step up and fix that, but we'll see.
Yeah, I hope so. You know, there was I think even like Phoronix had written about it. Like there had been a job listing for like an open source driver, graphics driver person or open source GPU driver like position, and it went away. So I think the hope was that they filled it. But thus far, I don't think there's been anything that the Imagination has like announced.
Yeah, they
But I
haven't
think,
announced anything, but they made some pretty strong statements at the RISC-V summit in 2019 about wanting to
okay.
commit to being more open. So we'll see what happens.
Yeah, I would hope so. For the purposes of Android, I don't think it matters much, but for like overall like ecosystem with like Linux, it would be awesome to have
Yeah,
support in Mesa. You know, I think that would be like the ultimate goal would be to have like
I think
support.
it makes a difference in Android as well, just because like at the moment there's really only like two or three GPU cores that like a RISC-V SoC partner could license. One of them is Vivante,
Mm,
one of them is Imagination's technology, and then depending on process, you might be able to license RDNA from AMD, but that's pretty much
mm,
it. Like everything else is all either proprietary to a manufacturer like Adreno for Qualcomm, or
yeah,
is based on ARM, and I don't see ARM licensing any RISC-V people their stuff.
yeah, yeah. So that's a good point because when it comes to RISC-V, it's gonna, you know, it's people need to get GPU IP, right? So
Yeah,
um yeah, that would be good. I mean, that's why like I do have warmer feelings with when I hear of Vivante because I know there's Etnaviv, but I'm not sure. I other outside of this specific design, I know I've seen a lot of companies that are doing RISC-V also working with Imagination. So it would be great if there was a path there for open source driver, because like I've suffered for like a decade with Imagination on TI SoCs, since I'm involved with the BeagleBone, and that's always been a source of frustration that there's not you know, open source driver there. So but you know, I think there must be pressure, right? Because like all the other GPUs that I can think of all have open source drivers now. So like
yeah,
Adreno and Vivante and even the ARM stuff now, right, has pretty
yeah.
good
There's
support.
the
So
Panfrost project that's been slowly but surely reverse engineering enough of the drivers to get ARM to go, okay, fine, we'll support it.
yeah, yeah. So it's really just imagination. But your point being in the world of RISC-V, it's mostly going to be people. It's, you know, it's they need to have something they can license, right? Which
Yep,
is going to probably be Vivante or Power VR, Power VR. So yeah, it would be good to see. You know, but we'll see. So yeah, I'm not sure what the answer is there, but
that's cool. I was just curious.
I do. So let me pull up the calendar because so David Chen is one of the people that he's one like the main people behind the RISC-V stuff at Alibaba T-Head. He's also now a co-chair of the software committee. So over all these different software related working groups and special interest groups is the software standing committee or horizontal committee. The words definitely change over time. I think in the calendar, it's called the Software Horizontal Committee. That's not what I want. So if you, anyway, so November 25th, we just had it, I think, last week. So the next one is November 25th. So this is both Philip, I forget his last name. He's one of the chairs, and the other chair is David Chen. from Alibaba T had. So this is also a good one to attend because it covers basically what's going on in all the different software related and platform related special interest groups and working groups and stuff like that. But David Chen's part of that, so might also be a good one to join if you wanted to ask about what's going on there. Or I could also give you his email too if you wanted to get in touch, because
with luck, might be able to catch up with, get some of these questions answered in December. So we'll see what happens.
Oh yes, yeah, that's a good point too. Yeah, yeah. The other thing I should have included here, because I think it happened after this, was that Alibaba T had also open sourced the design, like the RTL for all their cores, which I think happened after this talk maybe. So that's another pretty exciting thing. So, but yeah, I guess to go back to Android here, there's more information in here about the things they changed. I think this is kind of a good summary of like where they're at, which is, it runs, but there's a lot of room for improvement.
I mean, the fact that they're already at 50% performance is just awesome. Like
yeah,
that,
yeah.
it says so many good things about the RISC-V ecosystem.
Yeah. Oh, and then here is the link to the board, which I think it was like on AliExpress or something like that. I forget now, but I think also it might have run out, but I'm sure they'll make more. I feel like there's something wrong with my Chrome now because that didn't come up either. But if you check the slides, the links are in there. Yeah, so I guess if you're interested, join that SIG email list, and I'm sure there'll be updates there, but in the future. But it's pretty exciting because going back, like in January they announced it, but prior to that, like I think we all were assuming it would be several years before we'd have Android running on RISC-V. So I think I've been surprised by the pace of all this work. So I think it's quite exciting. And then the flip side, or the other side of this, is hopefully at some point we'll get some handset manufacturers or device manufacturers that maybe start using this in actual devices, which should hopefully accelerate things.
I got a feeling that's coming, especially with probably from like MediaTek and maybe High Silicon. But we'll see. Like I'm excited to see what's gonna come of this in the next couple of years.
Yeah, definitely. And yeah, I think there's like a huge incentive for companies outside of like the US to design their, or US and the UK to like design their own RISC-V processors, right? So like, well,
I also know that both of those companies are already using a bunch of RISC-V cores in their stuff, and like so Samsung and
right.
Qualcomm and various others. So it's at this point, I think it's just a matter of time.
Yeah. So I'm excited. I think that'll really, if there's Android RISC-V devices, I think that'll really hopefully the same thing that happened like once there was like kind of the proliferation of single board computers with cheap ARM SoCs, right? Because they were building these ARM SoCs for all these Android devices, right?
Yeah, be able to repurpose them to be actual Linux computers.
Yeah, so hopefully we get the same sort of thing happening with RISC-V, right? So I think that's definitely a thing to be excited about in the future. Oh, this was one. So there's been like a fair number of like boards announced recently. I think now that the Allwinner chips are starting to flow, like I've seen that, well, even just as a random person, you can now buy them on AliExpress, but I'm sure there's probably also other ways to get them in larger volume. And we're almost into next year, so I think the guidance had been like next year Allwinner would start selling them outside of that one dev board that Allwinner made. So I saw this pop up on Hackster.io, which I thought was pretty neat. Because it was designed in KiCad, and they've shared all the design files for it. So it's kind of a basic board. And the other thing that I found interesting here was they talk about the Allwinner F133, which seems to be basically the D1 with system in package with 60, I think it's 64 megabytes of DDR. So This kind of reminded me of what they did with ARM, where they would have versions that had integrated memory. I think it was like the old chip computer, the CHIP computer was using those like a long time ago with ARM. So looks like a similar thing where they just packaged in a limited amount of DDR, which I think is nice because then it makes it really easy to design a board, right? Because you don't have to do the high speed signals, right? So you've got your DDR in there with the SoC. So that's I think make it easy to design your own, right? Because you don't have to deal with all the DDR signals. So I thought this was kind of neat, and the person shared their KiCad files here. So I think if you wanted to build it, I guess you'd have to go on AliExpress and find the chip and buy it. But like I saw links to like, I didn't try and order a chip myself, but I don't know if you've seen anything different, Fue, but it looks like you can now at least get the chip on AliExpress, so people could start building their own PCBs if they wanted.
Yeah, but I think I will be more focused on the Michael Simmons stuff and and the new T-head chip, right? Yes, there's a more and also maybe I don't know if you got this news, maybe you got it, but Shangshan maybe have silicon later, and that will be pretty amazing. It will be how to say it, it's a first really open source code RISC-V CPU. So I may pay attention on that, and
what's
I will let you know, guys.
How do I spell that?
Shangshan, it's a mountain in China. Shan is mountain, and Shangshan is a famous mountain in China. So it comes from China Academy of Science. I'm not sure if you.
Yes. Yeah, I think I have that. Yeah, if people grab the slides, I've thrown other things in here which we don't have to go over, but just like the specs that are in review, and then some of the different working groups, platform spec. But all the way here at the end, because last time the one that we had that was that was more aligned with the time zone in China.
Yes, yes.
So this is out of the Chinese Academy of Science, and then I believe last time you could check the recording. It should be on the RISC-V YouTube. Is one of the people involved in the project, actually he joined and talked about this a bit.
Yeah, we may have a silicon very soon. Yeah.
Oh, great! I was trying to see.
But I will let you know once they really announce that. Yeah.
Is this? No, that's not that. So I'll just toss the link in here if people are interested. The last one we did, that's not it. You have to go to RISC-V YouTube. How do we get to RISC-V YouTube? Maybe that? No, whatever. I'll send the link later on. But last time, yeah, someone joined from this project and talked about it. But yeah, this is the thing. So you're saying that the tape out is going good potentially?
Yeah, the tape out is going good. Yes.
Cool. And this is open source design, open source core that they designed out of the Chinese Academy of Sciences. Let's see. Yeah, there's also this FAQ, which I think has some other good links in it. Oh, I think you helped us last time, but I think the idea here was that the 5.3 core mark was above the Sci-Fi FU 740. So the idea would be like it's a more powerful processor than what's in like the unmatched board potentially.
Actually, the actual silicon, the core is better than that.
Okay.
Yeah.
So like I guess
it's the data message actually.
Okay. So it's like I guess the exciting thing is that it's higher performance than anything we have right now, right? In terms of dev boards. Yeah, so that's pretty cool, and it's open source, so that's pretty exciting. Oh, and yeah, we also talked about, yeah, because the person from this project did join along with Wei Wu, and they were also talking about how in China it can be slow to use GitHub sometimes. So you also have Git.
Yes.
Yeah, which is like it's they kind of like try and mirror the content between GitHub and Git, but it's also, they also have the project on Git. So, which I thought was interesting because I didn't really realize that before, that cloning from GitHub can be slow if you're in China.
Yes, every time when I update my kernel source code and U-boot, I will use proxy.
I'm trying to think of where's the link for the Allwinner or the Alibaba T-Head announcement about open source cores. That was pretty cool. Oh, here.
Yeah.
This is a good article. Yeah. So this was pretty exciting. And I saw actually there's a Telegram group for people interested in the Allwinner D1. And I saw people were actually going through I guess this is the system Verilog of like the MMU, which was kind of interesting. It's kind of neat because like if you're working on the drivers in like Linux, then you can also go and look at the actual RTL for the processor, which is, I think, is not often the case, right? You can't just go look at the RTL usually for like an SoC that you're working with. Yeah, so I think somewhere in here is like, yeah, this is like the RTL for the processor. Like I'm like, so I guess the MMU, and then I believe I read somewhere that this is system Verilog. So yeah, so it's like under an Apache 2.0 license. Pretty neat. I only know a little bit of Verilog, so I don't know if I'd understand this, but yeah, it was neat. I saw someone working on kernel drivers, and then they were like pointing out places in the Verilog which like correspond, like, oh, here's actually where the registers or the CSRs being defined, which I thought was pretty neat. So that's pretty exciting because I mean, I don't think there aren't really any other chips that people are making that have an RISC-V chips that people are making that have an open source core, I think, as far as I know. I mean,
it's hard. Yeah, there's a lot. There's like when I got the Hi5 Unleashed, I cannot find this document. I need to go try and track it down again. But Sci5 released a document with the Hi5 Unleashed that had a here is all of the proprietary IP, like every single thing listed out. And it was a fascinating discovery of like how much stuff is proprietary and how hard it is to build something that doesn't have proprietary stuff that you can't necessarily get licensing in. I remember early on, people were really upset with Sci5 because the zero stage bootloader and the first stage bootloader weren't open, and Sci5 had to go back and work with IP partners to be like, can we publish these magic numbers? And that's really what it boiled down to. But like, people were still pissed because it's like, oh, you're just writing a number to a register. This doesn't tell us anything. It's like, yeah, but that's how it works.
Yeah. Definitely, like with the SoC, I think there's really no one that's thus far been able to make like an SoC that's like completely open. Well, there are people that are doing open source silicon designs with that 130 nanometer Google Skywater, but they're microcontrollers, right? So they're not like full.
Right, and because they're 130 nanometer, like you're not necessarily going to be able to get the size or get the speeds that you need in order to run full blown RB64 stuff, complete with MMU and all of that jazz, in order to actually like run Linux on it. It's something approaching a reasonable frequency.
Yeah, and I think the DRAM is also a big problem, right? Because, we now have like open source IP for SRAM, but only a couple K, right? So there's not really a solution for DRAM yet. But I think I think the thing here is this is just the CPU core, right? So this is just the CPU core. But then of course in like the D1 or even that Alibaba T-Head ICE SoC, there's probably all sorts of other IP in there, right, for the peripherals and the controllers.
Yeah.
But
some of that stuff is open, but like, it's funny because things that you would think are exceptionally basic and simple tend to be closed IP, like PLLs. All of the PLLs are closed IP because they're proprietary to the process upon which that you're building it on.
Right. Yeah, that's interesting. Like, because there's a lot of like the little kind of like the more analog things, right, that are always going to be specific to the fab. Yeah, so I'm pretty excited about this because it will, like, if you can go buy an all-winner D1 now, and you can actually go get the RTL for the core, you know, not for the whole SoC, but at least for the core, which is nice. You know, hopefully someday more of the peripherals will be open as well. But I think that's what the Chinese Academy of Science was doing. I think they had talked about, let's see, somewhere in here they talk about the IP that they're trying to use, and of course, I'm sure they still have to license things like DDR and USB, but they talked a bit about yeah, some of the things that they had used in their project, which is nice to get more things to be open.
Someday it would be great if there was some open DDR IP, like even if it isn't like the latest greatest supports everything, if there was just something that was open, it would. I think that would be like massive floodgates to people being able to do stuff.
Yeah, I think the best I've seen in terms of memory is in the power community. There's a company, I think, is it Raptor Engineering? Okay, so I believe Raptor Engineering, they are really good when it comes to like the memory controllers. Now, like the RTL is not open source, but they use memory controllers in their systems that like have like no proprietary firmware at all.
Oh, cool.
Yeah, because I was talking to them about that because they were making the point, like, you know, on these RISC-V dev boards that there's, you know, still things like, you know, the magic numbers for the DDR controllers and things like that. And they were talking about how with their power workstations that they had like put a lot of effort into that, but
we're doing a lot of work at Tormem with OpenCAPI and OMI and things like that. So I'm hoping that we can utilize some of that stuff and kind of bring it over to the RISC-V world as time goes on. But same thing, like a lot of it is closed because things like timing information and like how you go and do cast latencies and all the refreshes, like it's hard, like it's really hard, but maybe someday it'll get better.
Yeah, you were talking about the sci-fi stuff, and this is a while ago now, but I thought this was a really interesting blog post because it talked about from this person named Troy. So this person, like, he talked about the process they went through to get the bootloader code open sourced.
Yep, that was a fun time.
So this is both, I guess, the boot ROM, like this is the code for the masked boot ROM, I believe.
Yes, yeah, this is the 0-stage bootloader. So this is what's baked into every one of the U540C000 chips.
Which is pretty neat because I don't think I've ever seen the mask ROM code get published before, the source code for something. So that's pretty neat. And then I know what they ended up doing here was they ended up getting U-boot SPL to run is like the first software bootloader. And that actually, the memory, I think the DDR controller like settings are just in device tree, which is, I think, kind of a pretty nice solution. So I think, I don't know where it is, but if you look at the device tree for those boards, they have something that U-boot SPL picks up for the DDR timings, which seems to be like a pretty nice way of doing it. So
it's getting better.
Which some of the other boards I've looked at, you know, they're not in that position yet. They have you know, the first stage or the first software bootloader, which I guess sometimes is called the second stage, but you know, the first thing that runs after the
you got to go through proprietary bootloaders before you can get to open bootloaders, and then So
like the point where you can replace that stuff with U-boot SPL. So you just have mask-rom to U-boot SPL. A lot of the other boards I don't think are in that position yet. I know with the Allwinner D1, like Samuel Holland had been working on that, trying to replace the vendor bootloader stuff, but I don't think that they've gotten there yet. So, but that's, I think, the goal for like most boards, to get to the point where it goes from the mask-rom into U-boot SPL, which is, I guess, the ideal thing. Do you know, Fue, like what the latest is with the boot flow on the D1?
For now, I think, yeah, the SPL still there, but we are using the SPL provided by Allwinner, because it contains some low cost power efficiency code. So it's a little bit it consuming some time to replace it. But U-boot is upstream at some patch on that, and the Linux kernel could be 5.15. So we can use grub to boot the latest kernel. It's no problem at all. So the boot flows, the SPL from Allwinner, U-boot upstream, and grub upstream, grub at some patch, and Linux kernel to Fedora. Yeah.
Nice.
Yeah.
Yeah.
That's the picture you are showing. Yes.
You have nice graphics. I like the graphics you made. Everyone should have to make a nice flow chart for their boot process.
Yeah, thank you. Yeah.
But in this case, this is, so when we talk about SPL, this is
the Allwinner code from very date U-boot.
Okay. So I guess the real meaning here is SPL is a second program loader, which I guess would be second because we consider the mask-rom to be first. It's a little confusing though, because like with Sci-Fi was calling their mask-rom 0 stage, but then yeah. So I guess it depends on your perspective of how you index, right? If the mask-rom is the 0 stage or the first stage. So I guess in this instance, we consider the mask-rom to be the first stage. So this is the second.
Yes, Bootloader is first stage. Yeah, they have and we are working on the 5.15 kernel RPM for D1, and yeah, and I think we can put 5.14 on that, no problem at all. And we are working on 15.
Nice. Is there anything? Did you want to share anything on the screen, or if anyone else wants to? Like
for now, I haven't prepared.
Okay,
I had just finished meeting with my boss, so yeah, I haven't prepared anything. Sorry, but yeah. What is the next time? I definitely can do that, guys. Yeah.
And that's the one that's kind of more aligned to Asia, anyways.
Asia one. Okay, sure.
That's let me pull it up here. Okay, so next week, which is going to be, I think, Thursday morning for you. So it's 7 p.m. at night here in the west coast of the U.S. So I think that would be the morning.
Yeah, I'm gonna prepare it for you. Yeah, no problem.
Yeah, if you want to like do a presentation, like, you know, that'd be cool. Or if you just want to share your screen, you know, that would be.
Yes. Okay. Okay.
And I guess if anyone else is on here, like, feel free to unmute or say anything you want, or if you want to share anything. I guess we're come up on an hour now. Like in the past, we've gone like 2 hours, or it kind of depends on people's interests. But yeah, like I think that's kind of most of what I had today. But did anyone have anything else they wanted to share? I don't know. Otherwise, I guess I think it's getting late in China.
Yeah, maybe I can. I'm not sure if let me check if my colleague has translated to English, because we have something have just finished. And let me see. And Yeah, some of these things still Chinese, but I think something we can share with you guys. Let me see if I can show my, can I show my screen?
Yeah, let's see. So I'll stop, and then can you try and share now?
Let me, the host disable, the participant share the screen. Yeah, no worry, but I can show you this link. Maybe you can check. Maybe you can share a screen. Yeah. Yeah.
Are you able to share?
You share a screen, no problem. Yeah.
Oh, okay.
You share a screen. Yeah.
Let's go back here. Is this it?
Yes. Just roll down a little bit.
I think I can translate too.
Yeah, no need actually. Yeah, okay, cool. But I don't think it's really right. But here. Yeah, it's not important, but just here. Yes, this one. So we already can produce OpenEULA and Fedora imaging for this platform, and from this build platform called OEPKG, what we need to do just do a push to the Git, and then he will generate the imaging for that. So you can download the imaging, have a try. But we already tried the OpenEULA disk imaging for Starlight D1 and Fedora imaging for Starlight D1. So you can have a try here. Yes, there's some instruction for how to deploy the imaging below. So yeah, that's something we're just working on. We just finished that, and we haven't got time to really translation everything, but nearly done. Yeah.
So what is OpenEULA? It's Huawei's
yes, it's
okay.
an open source. It's an open source version from Huawei OS, Huawei OpenEULA OS. So we call it OpenEULA for a long time. Yes, there will be a OpenEULA summit in Beijing, but because of a COVID-19 stuff, it may be I cannot go to there for RISC-V stuff. But it's not just for RISC-V. It's something like Fedora. Yeah, it's a Linux distro.
Is there I guess is there another distro that you would say it's similar to, like Fedora or Debian or
yes, it come from originally come from Fedora 29 or CentOS 8, but they already branched. So it's not, for now, it's nothing to do with Fedora. They going their own path. So it's another distro development in China. Yeah.
Nice. Cool. Awesome. So you have this set up and running on a server in China then? Building all
yes,
these things?
Yes. Okay. It's kind of like a Koji. So you can see below Jenkins and more. You can see the left side. You can see more. Yeah, there's some instruction for how to use that, how to use the imaging. Yeah. And below that you can see more, and you can see Jenkins and which that's wrong. They should be Koji. More.
Where do I click?
Left side.
Yeah.
Down a little bit down. Yeah, down. Yes.
Oh, Jenkins.
And then you can see something else. The thing below Jenkins, you can click the link.
Oh, okay. Which, or maybe that's translated.
Which?
Oh, Koji.
It's Koji. Yes, it should be Koji. Yeah.
Oh, yeah, I guess that was a Google Translate.
Oh, yeah, it's a Google translation. Yes.
Okay.
So we are building the imaging here. You can see Fedora minimum imaging, Fedora imaging for JH7110, and you can see more. Yes.
What's arts?
That's the background for their distro. Yes, they want to change your background. That's it.
Oh, okay. Cool. Nice. Is this a Wi-Fi Broadcom?
Yes, it's a Wi-Fi firmware. Yes, it's not important. If you want to check all the imaging we build, you check the tasks. The fourth one. Tasks.
Yeah. Okay.
Tasks.
Like this?
Fourth one. Tasks.
Oh.
Yes,
Okay.
this one.
Okay.
Tasks. And then choice finish. Close. This one. Yes, close. And
okay.
mass choice appliance.
Which one?
Yes. Appliance. Mass. The how to say drop down list.
Oh,
mass.
appliance. Oh, okay. Okay.
Yeah, appliance.
Right, okay.
Choice appliance.
Okay. Cool.
So you can see all the things we have built for RISC-V.
Nice. It's a busy server.
Yes, it's busy server. We have 72 QMU builder for RISC-V.
70 builders?
72
builders. Is that software instances or is that actual like server?
It's just a QMU for now because we don't have a server, and unmatched and D1 or maybe Starfire. The kind of a development board is slower than QMU, so we are waiting for the more advanced server. Yeah, next year.
You know, I was one question. I'm buying a new computer right now, and I was wondering, what does one actually need to build Fedora? Like, if I were to run Koji, like, how much memory do you need?
If you want to build an image, is that right? Or Koji?
Yeah. But like, I mean, I don't think I would, but just to say I wanted to build Fedora. Like, how much memory do I need?
Let me see. Maybe 16.
Oh, okay. I was looking at like getting 32 or 64 gigabytes. Okay, so it doesn't need
16 is quite enough because you just need to run one builder with one Koji, so it's not very hard. If you just want to build a Fedora image, you can just use this instant. You can register for free and try to use this instant.
Okay, cool. Nice.
Yeah, I can share with you guys.
The thing that has me buying a new computer is actually Yocto, trying to do Yocto builds. I don't know if you ever use it, but I mean, I thought it would have been similar for Fedora as well, but just like trying to build things like Node.js and Qt, it's just like I run out of memory. Even I have 16 gigabytes right now, and it runs out of memory, and out of memory kills a bunch of stuff when I try and build some of those bigger packages. So
yeah, normally we have A core, so we may need A multiply 4, so 32 gigabyte.
Okay. Cool. So we'll hopefully we'll get like a RISC-V board with 32 gigabytes in the future, so you can do.
Yeah, I hope so. Yeah, I hope so. we will. I guess next year. Yeah.
Okay. So is that the you know, I didn't get a chance to talk to him, but I saw Matthew Miller from Fedora was at the conference in Seattle that I was at. But is it correct that it needs to be native before it can be a real Fedora? Is that the rule?
Sorry again.
Does it need to build natively before it can become a real Fedora, like an official Fedora?
We already build it always natively. The only problem is we don't have the right RISC-V server can put into the Fedora infrastructure. So that's the only problem. So we are waiting for a RISC-V server.
Okay. So can you put like an unmatched in it, or that's not sufficient?
No. Yeah, but it's just one one development board, we want something like the 2U or 1U real server can own the rack. Can it get put into the rack? Yeah.
Okay. But if someone like put the unmatched into like a 1U, would that work, or does it need to, you need more power?
Yeah, it may work, just a little bit slow. We expect it can be much faster than unmatched. But yeah, if people can use unmatched to build real server, that should work. But BNC, yeah, we need BNC on it.
Oh, the BN, okay, you need the management.
BNC on it, yes.
Yeah. Okay. All right. Yeah, well, okay. I mean, next year's not far away, right? So we're only 2 months away from next year.
Yes.
Cool. All right. So you think you'll be around for the one next week then?
Sorry again?
You think you'll be able to be on the open hours next week, next Thursday morning?
Yes,
I guess.
yes,
for
of
you?
course.
Okay.
I will be there. I will be there. Yes.
Cool. And hopefully we'll get Weiwu as well, I presume. And
yes, at that time if that's an Asia one.
Yeah, that's the Asia one. Yeah. So it's in the in the evening for me. So yeah. I might have a beer instead of a coffee for that one.
Yeah, I should. Yeah, I should prepare some snack beside me. Yeah.
Okay. Cool. All right. Well, I mean, I haven't. No one else has really really unmuted themselves yet. So yeah, I don't know. I think we've. I think we could probably bring it to a close for today. And you know, we can pick it back up next week if that sounds good.
Yeah. Yeah.
Okay, and then you can go to. Well, you don't.
Yeah,
you don't go to.
I can call it a day.
Yeah, you're probably not going to go to sleep anyways, but at least you can. I know you stay up late, but yeah.
Okay.
Cool.
Okay.
All right. Yep, good to talk to you, and thanks everyone else for joining. And we'll be back in about 7 days.
Yeah. Thank you.
Right.
Thank you. Okay.
Bye. Bye.
See you guys. Bye.